So, quick review on limiting and excess reagents. We talked about this in the last lesson, and we said that unless a reaction is perfectly balanced, one reactant will run out first. And so, for example, let's suppose that we're cooking brownies, and we have available 15 eggs and 40 cups of flour. And so, if you think about it, is that unless we got really lucky, that for any recipe, something's going to run out first. If I try to make as many brownies as I can out of my 15 eggs and my 40 cups of flour, is that either my eggs are going to run out and I have excess flour left, or my flour is going to run out and I'm going to have eggs left over. One of the two is true. The thing that's left over afterwards, and so in a chemical reaction, if I start off with two amounts of reactants, one reactant will be left over at the end, and that reactant is called the one in excess, and the one that ran out first is called the one that's a limiting reagent. And so this limiting reagent, the one that runs out first, this is the one that determines what everything else will, and what everything else will be, what the masses of the other products will end up being. And in fact, actually even what mass of the excess reactant will be used. Sort of think about it like this, is that once again, if I have 15 eggs and 40 cups of flour, whichever one of those two that runs out first, whether it's eggs or flour, that's the one that's going to determine how many brownies I can make. Because you can't make more brownies than you could make with the one that runs out first. If something runs out, then that's as many brownies as you can make. You can't make any more. And so this limiting reagent, this limiting reactant, is the one that determines what the amounts of everything else is. And so the one that's not limiting, we said, is in excess. So I give an example. If I react 10 grams of oxygen with 10 grams of hydrogen, and we're told that oxygen is a limiting reagent, then we know that any calculation we do will use that 10 grams of oxygen, not the 10 grams of hydrogen, because the hydrogen is in excess. But what if I wasn't told anything about oxygen being the limiting reagent? What if I wasn't told anything about the hydrogen being in excess? If those two things were just completely unknown, how would I manage to solve this? What I would have to do is I would somehow have to be able to figure out which of these two is the limiting reagent. Is it oxygen or is it hydrogen? And so that is going to be what we're going to talk about next. How do you figure out which one is the limiting reagent? So, in cases where the masses of all the reactants are provided, but you do not know which one limits the reaction, you must find the limiting reagent. That's our goal here. And so to do this, so basically once again is using our analogy here, is if we have 15 cups of flour, 15 eggs and 40 cups of flour, is to figure out how many brownies I can make. That's my goal. I want to figure out how many brownies I can make. I have to know which one's going to run out first. And so that's our goal here. If I can figure which one runs out first, then I can figure out how many brownies I can make. So to do this involves determining how much of one reactant would be needed to completely expend the other reactant. So once again, to our brownie analogy, is that what I could do, if I want to figure out which one's going to run out first, is I could say, if I have 15 eggs, how much flour would be used in a recipe that used up 15 eggs? If it turns out that, that 15 eggs is going to use up 30 cups of flour, then I would find, oh, I've got 40 cups of flour available. So I have some flour left over in excess. So if the flour is in excess, that means the eggs were the limiting reagent. Similarly, if I do my my recipe and I say I start off with 15 eggs, and it turns out that 15 eggs requires 50 cups of flour, then, which is unreasonable, but if it did, that 15 eggs requires 50 cups of flour, then I'd say I don't have enough flour. My flour ran out first, therefore my flour is my limiting reagent. And so whenever you were trying to figure out how many brownies that you needed, you would start off with 40 cups of flour and then figure out how many brownies you could make from that. In the first case, where 15 eggs only needed 30 cups of flour, since the eggs were the ones that were the limiting one, then you would say that to figure out how many brownies you'd make, you'd start off with 15 eggs. And so this is basically the process we're going to use. So overall, our first step on this guy right here is that we're going to want to write and balance the chemical equation. That's number one. Then number two, we're going to choose the amount of one of the reactants. Doesn't matter which one. I mean, I call it reactant A here, but really it doesn't matter which one it is. But choose the amount of one of the reactants and then stoichiometrically calculate how much of the other reactant would be needed to completely react the first one. And so this sounds a little bit confusing for step two, but if you think about it, what it means is this. If we have 15 eggs and we have 40 cups of flour. Pick one of the two. You can start with 15 eggs, or you can start with 40 cups of flour. And say we'll start with 15 eggs. So what we're going to do here. Figure out how much flour would be needed to react with 15 cups of eggs. Or 15 eggs, I'm sorry. And so once you've got that, it's like you talked about before. If it turns out that 15 eggs is going to need 30 cups of flour, you then can compare it with your total amount of flour. If it's more than the amount of flour you had, the flour runs out first. If it's less than the amount of flour you had, then the eggs run out first. If we are doing this, and that's sort of our step 3 that's right there. Just do the comparison. If the calculated result of B is less than the actual amount of B, then A is your limiting reagent. If the calculated results of B is more than the actual amount of B, then B is the limiting reagent. And so if we were to think of this in terms of like elements instead of brownies, it would be sort of like this. If I have 10 grams of hydrogen and 10 grams of oxygen, what I'm going to do is I'm going to start off with, say, my 10 grams of hydrogen. And I'd say, how much oxygen would be needed to use up 10 grams of hydrogen? I'm going to figure that out. And if I figure that out and that amount is more than my amount of oxygen, oxygen limits the reaction because I ran out of oxygen first. If that amount is less than my amount of oxygen, that means I have oxygen in excess. I have some left over. And so that meant that the hydrogen limited the reaction. And so in any calculation I do after that, I'm going to use the hydrogen if the hydrogen is the limiting one. If the oxygen is the limiting one, I'm going to use the oxygen amount, those 10 grams of oxygen.